In this video, we're going to solve exponential and logarithmic equations. First, we're going to solve exponential. So you got 81 to the x equals quantity 1 over 9 to the x plus 3. And notice our variable x represents some exponent. In order to solve this, we need to have a same base. So what I'm going to do is I'm going to change 81 to 9 squared. And 1 over 9, I'm going to change it to 9 to the negative 1. So what happens now is that you get 9 to the 2x equals 9. You multiply these two, you get negative x minus 3. Now, in order for these to be equal to each other, the exponent needs to be the same. So you get 2x equals negative x minus 3. So you end up getting 3x equals negative 3, which is x equals negative 1. And you could check your answer by plugging in to the original and see if they're equivalent. Graphically, what you could do is you could graph this as your y1, and you could graph that as your y2, and find the x value where they intersect. Now this example has 3 to the x equals 8. Unlike the other one, it is not possible to have a same base. So what we need to do is, again, the exponent is the variable. What we're going to do is we're going to change. We're going to put natural log both sides. Now remember the property of natural log, power property. You could put x in front of natural log. And in order to solve for x, we need to divide both sides by natural log of 3. Now we need a calculator to go further. This will be approximately 1.893. Now again, you could solve this by graphically. What you need to do is you need to graph 3 to the x and 8 and find the x value of the intersection point. So this is what I mean. When you graph 3 to the x and y equals 8, here's the point there they intersect. And notice they intersect at approximately at 1.893, and the y value is 8. Now we have a logarithmic equations. In order for these two natural log to equal to each other, they're only equal to each other as long as they have the same value inside natural log. So that happens when 5x plus 2 is equal to x plus 10. So solving for x, you get 4x equals 8, and x is equal to 2. Now you got to make sure that when you plug it in, these values are not negative, because natural log of negative number does not exist. This is what I mean. Natural log, let's say negative 2. When you use your calculator, you will find out that it doesn't exist. What about natural log of negative 5? Same thing. This number inside the log or natural log cannot be negative. So for this example, our final answer is x equals 2, because even though you plug in 2, these are positive. Now you got log of base 3. Log base 3 of 10x minus 9 equals 4. In order to solve this equation, what you need to do is you want to change it to exponential form. So remember, logs are exponents, so base is 3. 3 to the 4th is 10x minus 9. So 3 to the 4th power is 81. And then moving 9 to the other side, you get 90 equals 10x. Divide both sides by 10, you get x equals 9. But let's check. When you plug in 9, you get 90 minus 9, which is positive, so it's okay. Remember, anything inside the log, it has to be, whatever is inside the log has to be greater than or equal to 0. Now you got log base 6 of 6x plus log base 6 of x minus 1 equals 2. Now in order to solve this equation, we need to use a property of logarithms. So first property we need to use is the product property. So we can rewrite this as log base 6x times x minus 1 equals 2. Now, you could distribute the 6x, or you could just rewrite it as exponential form first. So logs are exponent, so base is 6 squared equals 6x times the quantity x minus 1. So this becomes 36 equals 6x squared minus 6x. What I like to do is I want to divide everything by 6. You could do that because this is an equation. And you end up getting 6 is x squared minus x. And moving 6 to the other side. And you could solve this quadratic equation by factoring. So you end up getting x equals 3 or x equals negative 2. Now you got to be careful. Remember, we said that whatever is inside the log, it has to be greater than or equal to 0. No, I'm sorry, greater than 0. So when we plug in 3, that's 18 is okay. When you plug in 3 over here, it's 2. So 3 is okay. What about negative 2? What's 6 times negative 2? Negative 12. And log base 6 of negative 12 does not exist. So that is an extraneous solution. So you only have one solution, which is x equals 3.